right, Algebra 2 students, we are starting Chapter 3. This chapter is over polynomial functions. Basically, what a polynomial function is, it's either a monomial or a sum of monomials. All right, so that's the definition, and let's go ahead and turn to page 2 here in your note packet, brand new note packet. And our first learning target is I can classify polynomials. So here for example 1, we have an example of a polynomial. So you notice that this is a sum of 3 monomials making up what is called a trinomial. So how do we classify these? Well, your first step is to put the polynomial in standard form. What standard form looks like is that all like terms are combined. So let's check that first. Do we have any like terms in our example? No, not in this one. So we can go to our second step, and that is to order the terms by degree. So you're going to start with your highest exponent and go to your lowest exponent. So the degree is the exponent here. So I have a degree of 1, a degree of 0, and a degree of 3. So 2x to the third would come first. And then minus 4x, and then plus 9. So I put it in order from highest to lowest. All right, so the degree is the highest exponent. So the degree of the whole polynomial would be this highest exponent of 3. And then the leading coefficient is the number in front of that highest exponent. So my leading coefficient would be 2. I'm going to abbreviate that with LC for leading coefficient. And now lastly, we need to count the number of terms. So terms are separated by the plus and minus signs here. So my first term is 2x to the third, second term is negative 4x, and my third term is the 9. So I have here a 3-term polynomial. So this polynomial has 3 terms. Okay, so let's practice this. We've got a couple more examples to look over. Why don't you go ahead, pause the video, and try A and B on your own. All right, let's check and see how you did. So make sure you put it in standard form first. So combine any like terms and then put them in descending order, starting with the highest exponent. So it would look like that. And then you're ready to classify it. So this is a polynomial with 1, 2, 3, 4 terms, and it has a degree of 4 and a leading coefficient of negative 3. So the leading coefficient is negative 3, the degree is 4, and it is a 4-term polynomial. All right, the next one. Look to see if you can combine any like terms and then put them in descending order. And that is what you end up with. Leading coefficient is 2, positive 2 there. Degree is 6, highest exponent is 6. And then this has 1, 2, 3, 4, 5 terms. Okay. Let's move on to our next learning target. So this will be our second and final learning target. I'm on page 3 now. And this is the end behavior. So end behavior is describing what the graph is doing on the left side and the right side, on the ends. What is the end behavior of the polynomial graph? Okay? So let's look at number 1 here. Here's your polynomial. Go ahead and plug that into your graphing calculator or Desmos. You can pause the video to do that on your own. But you would get this graph right here, something that looks, this is just a rough sketch, but it looks something like this graph. So let's talk about the end behavior. Well, the end behavior would be it's rising on the left and it's also rising on the right. So if I'm looking at my x-axis here, the right side, x is approaching positive infinity, and as the further I go to the left, I'm approaching negative infinity. So now we're describing what is the graph doing. Well, is as x approaches positive infinity, or on the right side, the graph is going up, approaching positive infinity. The y is going up, positive infinity. And as x approaches negative infinity, or on the left side, the graph is also going up. The y is approaching positive infinity as well. So it's written like this. As x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches positive infinity. Remember, f of x is a fancy way of saying y. F of x is the function notation for y. Okay, so let's make some observations here. This is my leading coefficient, and it is positive. This is the degree, the highest exponent of the polynomial, and it is an even number. So I have a leading coefficient that is positive and a degree that is even. Let's see what happens in this case, case number 2. If you were to put this polynomial negative x squared plus x, you would get a graph that looks like this. So it's falling to the left and it's also falling to the right. So as x approaches positive infinity, f of x, or the y value, is approaching negative infinity. And as x approaches negative infinity, f of x is also approaching negative infinity. So let's make some observations about this. Our leading coefficient is negative this time, and our degree is even. So I have a leading coefficient that is negative with a degree that is even. All right, let's look at this third case here. So 2x to the third, the graph looks like this. As x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches negative infinity. Observation here, leading coefficient is positive, degree is odd. 3 is an odd number. All right. And then lastly, number 4, graph it there. As x approaches positive infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches positive infinity. And this is with a negative leading coefficient and an odd degree. Okay, so let's take all these observations, put them together, and we're going to put this information in a chart. So here's our chart. So we've observed on the last page that if we have a positive leading coefficient and an even degree, it's going to rise to the left and it's going to rise to the right. So in other words, f of x is reaching positive infinity. And if we have a positive leading coefficient with an odd degree, we found that it falls to the left and rises to the right. So f of x is approaching negative infinity and positive infinity there. And then if you have a negative leading coefficient with an even degree, it's going to fall both to the left and to the right. So f of x is approaching negative infinity there. And then lastly, a negative leading coefficient with an odd degree rises to the left and falls to the right. So f of x is approaching positive infinity to the left and negative infinity to the right. Okay, we're going to keep that chart handy. And now we're going to jump into our next learning target. I can determine the end behavior of the graph of a polynomial. So we're going to use this chart to guide us here. So here are our steps. First of all, you always want to make sure that it's in standard form. Rearrange it if you have to make sure that it's in standard form. So let's look at this first one. Letter A, example here. So I'm going to check my degrees. 6, 5, 4, 3, 2, 1, constant. So yes, we're good. It's in standard form. And then we can jump to our next step. Determine if the leading coefficient is positive or negative. So our leading coefficient is here. It's 2. Leading coefficient is positive. And then the degree, 6. 6 is an even number. So I'm looking at a positive even. So I have determined my leading coefficient, if it's positive or negative, and I determined if my degree is even or odd right here. Now I'm going to take this information and look up to my chart. So I'm looking for a positive leading coefficient with an even degree. So I'm looking at this box right here. So it's rising to the left and rising to the right. Okay. So I'm going to go ahead and sketch those ends. Rising to the left and rising to the right. So I can finish this graph by plugging this into Desmos or my graphing calculator, and I would see that the graph looks something like this. Now I can figure out my end behavior. So here's my x, here's my y or my f of x. So as x approaches positive infinity, f of x approaches positive infinity. And as x approaches negative infinity to the left here, f of x approaches positive infinity. And that would go here for my end behavior. All right, go ahead and try B on your own. All right, let's see how you did for B here. So looking up here, my leading coefficient is negative with an odd degree. Leading coefficient is negative with an odd degree. So I'll look up at my chart. So negative, odd, it's going to rise to the left and fall to the right. rise to the left, fall to the right. Rise to the left, fall to the right. And I'll plug that in and I'll see a rough sketch here. It looks something like this. So what is the end behavior? So as x approaches positive infinity, f of x approaches negative infinity. And as x approaches negative infinity, over here on the left side, f of x approaches positive infinity. All right, so that is my end behavior there. Okay, that concludes the lesson for today. You are ready to start your practice work.